Okay, Chapter 6 test. I had two different forms. They're almost identical. They're only slightly different, but I'll do A here, and if I have time, I'll do B. Okay, so on A, it's 3 and 3. If you graph the sign, you'll see that sign will go up to 3 by the time you get to 2. It goes up to, that pen is dying. Let's try this one. It will go up to 3 by the time you get to 2 as a sine curve. Okay? And this will go up to 2 also, but it starts at 0 and goes this way. And you can put in 1 into both of these. This is pi over 4 is square root of 2 over 2 times 3 is about 2.1, so it should have been a little bit higher here like this. And I think it actually peaks out there, and this one is flat here and comes up like this. And you can plug in 1 into that one, which would be 3/4, which is about right. And we're supposed to find the area between them. So I got the graphs. The area between them will be, if I do a slice, it'll be a dx. So it'll be integral from 0 to 2 of 3 sine of pi x over 4 minus, that's the top one, that would give me all of this area, minus the area under the other curve, which is 3x squared over 4 dx. And to do this one, this part of it, this can be split into two separate integrals, but I'm going to work with this one. If I let u equal pi over 4x, du would equal pi over 4 dx. And so I'd have the integral from 0 to 2 of, oh, actually, if I'm switching to u, it would be 0 to pi over 2. If I put 2 in for x, I get pi over 2. The 3 would come out, and this would become the sine of u, and dx would become 4 du over pi. That's what the first part one would turn into. And the second one is a simpler one, minus integral from 0 to 2 of this, so it goes to 3, and divide by 3, the 3's cancel, but it's going to be 3x squared over 4 dx. Integral of, so the 3 comes out, that'd be 12 over pi. Antiderivative of sine is negative cosine of u, and I changed my limits. You can change them back, so you can go to 0 to 2, but I changed my limits, so it's 0 to pi over 2. Cosine of pi over 2 is 0, so we get minus 0, minus a minus, which is plus, and put in 0, we get 1. So I get pi over 12 times 1, 12 over pi. And this, when I integrate it, becomes x to the third over 3 times 3/4, which becomes 1/4. And I'm subtracting this, and I'm going it from 0 to 2. If I put 2 in there, I get 8 divided by 4, which is 2. And that subtract. And then put in 0, and I get 0. And so that is my answer for that. Okay? And you didn't have to do it this way. You could have just used your calculator to calculate this value in decimal. But that's doing it the longhand way. Now this one. So if I put in 0, I get 1. If I put in 1, I get 1 over the square root of 2, which is about 0.7. If I put in 2, I get 1 over the square root of 5, which is somewhere here, and it goes like that. It goes similarly this way. And I want to rotate this around the x-axis so it'll have a mirror image down here. So disk method, I would just do a slice vertically. It'd be a dx. And the disk method is pi integral of r squared minus, there's no inside, so I don't have to do minus r. And I want to do it from 0 to 4. And my slice is dx. So this direction is y. And y is equal to this. So it's going to be pi integral from 0 to 4 of 1 over the square root of this squared. So 1 squared is 1. The square root of that squared is 1 plus x squared dx. The antiderivative of that is arc tangent of x, or tangent inverse of x, whichever way. So we get pi arc tangent of x evaluated from 0 to 4, which is pi times arc tangent of 4 minus arc tangent of 0, and that is arc tangent of 4 is 1.3258, and the arc tangent of 0 is 0. So we just have that other answer times pi, which is 4.165. So if you just typed this in, that's what you should have got, but I worked it out. Now I'll do it with ring method. So then I would slice this way, but that's going to be a little tricky because it'll be equal to the curve until we get to where however high it is there, and then we'd have to do just by itself. So ring would be the harder way to do that, so I wouldn't suggest it. Alright, this one, which I looked like several of you were struggling with, and some of you had trouble graphing this. So we got to go to y equals 8, so I would probably put my x-axis down here nice and low so I can get up to 8, and x cubed. So I'll put the y-axis here, and 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, and this goes like this. Not straight up, but almost. Y equals 8, and the y-axis is this there. And some of you rotated that around y equals -2, but it says x equal -2, which is here, which takes this point over to there, this point over to 1, 2, 3, 4, 1, 2, 3 there. Now, get the shape a little bit better here. So here's the axis, x equals -2, and it goes this way. All right. So this is -4, clear over here. This is -2. So disk method. So I slice it perpendicular to the axis. So I'll make a slice right here, which should be over here. So it's actually going to be a washer. And I'm going to do the antiderivative of pi large radius squared minus small radius squared d. Its thickness is in the y. And y is going to go from 0 to 8. And my large radius is, if I'm going from the x-axis, this is x. So the large radius is 2 more than x, so it's x plus 2. My small radius is always 2. But I need to be in y's, so I have to solve for x, and that would be the cube root of y, so it's going to be pi antiderivative from 0 to 8 of the cube root, that's y, to the 1/3 plus 2 minus, and that's all squared, minus 2 squared dy. Okay, so this is a binomial that I got to square, so it's going to be y to the 1/3 plus 2 times y to the 1/3 plus 2. So it's going to be y to the 2/3, y to the 2/3 plus 2y to the 1/3 plus 2 more, so plus 4y to the 1/3 plus 4 minus 4. Those cancel, and I get to do the antiderivative now, which is going to be pi 2/3 add 1 is going to be 5/3, so it's 3/5 y to the 5/3. 1/3 plus 1 is 4/3, so it's going to be plus 4 times 3/4 y to the 4/3. And there's no more. Evaluated from 0 to 8. The cube root of 8 is 2, to the 5th is 32, so I get pi 3/5 times 32 plus cube root of 8 is 2, to the 4th is 16 times 3, and that works. And then if I put in the zeros, I get 0. So I get 96 over 5 plus 48. Times pi. 5 goes in there, 1, 46, 9, and 1/5. So 48, 58, 67 and 1/5 pi. Work that out in decimal if we want. All right, now do it with the ring or shell method. So now I need to slice it parallel to the axis. So I'll make a slice right here, which should be matched over here. Be a shell, a ring. And the formula for that is 2 pi r. R would be out to there, which is going to be x, because this is x going to the graph, plus 2. There's r. And then 2 pi r times the height. That's this. But this is y, so it's going to be 8 minus y, and the thickness of that is going to be dx, and x is going to go from 0 to 2. It's 2 pi r times the height times the thickness. Okay. Oop, missed it there. 2 pi r times the height times the thickness of it, dx. So only thing I need to replace is the y, and y is x cubed. So this becomes 2 pi integral from 0 to 2, x times 8, x times x to the third, x times x to the third, which is, and minus x to the fourth, 2 times 8, and 2 times x to, negative x to the third, negative 2x to the third, dx. So I got 2 pi, that would become 4x squared, adding 1 and adding 1 to get 2, divide by 2. Add 1, so that'd be minus 1/5 x to the fifth plus 16x. That'd be 4 divided by 4, so it's negative 1/2 x to the fourth, evaluated from 0 to 2. The 0 produces nothing, but the 2 will. So I get 2 pi. 2 squared is 4, times 4 is 16. 32 divided by 5. 32. 16 and half is 8. Minus 0. So 16 plus 32 is 48. Minus 8 is 40. So that takes care of that, that, and that. 5 goes in there, 6 and 2/5. Minus 6 and 2/5. So that's going to be 33 and 3/5 times 2 pi, and hopefully 2 times this will be 67. 2 times 33 is 66, and this would be 6/5, so it'd be 67 and 1/5 pi. And they match. All right. This one. So we're pumping it out of this tank 6 feet by 12 feet, 3 feet deep. And this one we're pumping it 8 feet higher to something, some kind of thing that's 8 foot higher than this. So this is in the English system, feet, so we're doing the 64. So we got the density, 62.4 pounds per cubic feet. And then we have to turn that into a force, which means we have to multiply by the volume of what we're lifting. And that would be a slice like this. And I'll put the coordinate system right here. And I'll even make this be y and this positive x here. So it'll be a dx. It'll be, if that's y, it'll be 2y for across here. And this way will be 12. So there's the volume of the slice, and that will cancel that, and so I'll get a pounds, which is a force, times the distance I got to lift it, and if this is x, and I make it 0 there, that's x, and so I'll be lifting it x, 8 plus x. And I'm going to add these up as x goes from 0 to 3. So I have a lot of constants in here, and I have x and I have y. And it's dx, so I need the y to go away. And so this is over at 0 in the x, 3 in the y. And this is at 3 in the x and 0 in the y. And so that the slope is -1, so y equals -1x plus y-intercept 3. Or if you will, since it goes through 3 and 3 on the two axes, it's x plus y equals 3. Either way, you can see if I subtract x from both sides, I get that. So the y is going to be 3 minus x. 3 minus x, or minus x plus 3. So we have 62.4 times 24. Those are constants. That's a constant, but it's added. So I'm going to leave that, and I'm going to have the antiderivative 0 to 3 of, I've got the 2, the 12, that out. I have a dx left, and I have 3 minus x times 8 plus x. And I could type this into the calculator, and I'd be happy with your answer. But this multiplies out to be 24 plus 3x minus 8x, so minus 5x minus x squared. So I got 62.4 times 24, and antiderivative is 24x minus 5 halves x squared minus 1/3 x to the third. Evaluated from 0 to 3. The 0 is going to give me nothing. So I'm going to get the answer 62.4 times 24 times 3 times 24 is 72. 9 times 5 is 45 halves. 27 divided by 3 is 9. And so I get 72 minus 9 is 63. 22 minus 22 and 1/2. So that's 41 and 40 and a half. So I have 62.4 times 24 times 40.5, and I get 60652.8. This would be the work, so it's going to be foot pounds. Five, vertical rectangular tank. The top is 4 by 7, and it's filled with water to within 1 meter of the top, and it's 10 meters high, the whole thing, and that's 1 meter. The pressure is simply, let's see, it says, determine the pressure on the bottom. The pressure is determined by how deep it is. The pressure on the bottom is going to be 10 times the depth. So times 62. This is in meters, so we have to go 1,000 kilograms per meter cubed times 9.8 meters per second squared. This and this is a Newton. So we get 10 times 9,800, so it's 98,000 newtons is the pressure at the bottom. All you have to do is take the depth, the depth of the water. It's a 9. My mistake. It's the depth times the weight density, and that's the pressure at the bottom. Not the weight on the bottom, that would have been the force. And I think I told somebody that. But it's supposed to be the pressure. So it's just the depth times the mass, the weight density of it. So weight density is 1,000 times 9.8. That's the weight density times 9 meters deep, 8,200. Newtons per meter squared is the pressure at the bottom. If you were to hook up a hose on there, that would be the pressure. You can convert it to PSI if you want, but that's in the metric system. Now, the next thing was, what is the force pushing on this side? So at this one, we have to do some calculus. So I'm going to do vertically is x. I'm going to put 0 right there. And so this would be dx. And the pressure at that depth is going to be the weight density, 100 kilograms per meter squared is the mass density, times 9.8 meters per second squared makes it a weight density, newtons per meter cubed, excuse me. That's a weight density times the depth to find the pressure. So if that's x, my depth would be x minus 1. You could put x right there, and then it would be just x. I mean, put the origin right there at the top of the water, and then it would be just x. It just makes a difference in what the limits are. So the weight density times the depth is pressure, like we did in the front, in the first one, times the area of that. Well, it's going to be 7 by dx. That's the area of this rectangle. And we want to add up the pressure on all of these rectangles. And so this is going to be, this is in meters, this is in meters, and this is in meters. Cancels all the meters, and we get newtons of force. And so we want to add it up. Since I put x there, the origin there, it's going to be from 1 to 10. If you put the origin here, it would be from 0 to 9, and this would have been just an x. And either way works. The 7, that, and that all come out, and so we're just integrating x minus 1, which would be 1/2 x squared minus x, evaluated from 1 to 10, times 9800 times 7. And so I get 100 divided by 2, which is 50, minus 10, minus 1/2 minus 1. So that's plus 1/2. So 50 minus 10 is 40 and 1/2. Times 9800 times 7. And this would be in the force, so it would be in newtons. So it's, gotta get off. Oh, I got that. So it'd be 40.5 times 9800, the weight density, times 7. So the force would be 2,778,300 newtons, which is what I should have got if I would have just typed this into my calculator and did the area under it. Okay, this one. The problem would be going to infinity, so we do the limit as a or b goes to infinity of the antiderivative 3 to a of 2 over x squared dx. So this is 2x to the negative 2. The antiderivative is going to be add 1 and divide by that. That's negative 1. So I'm going to get 2x to the negative 1 over negative 1, which is negative 2 over x. So we're working out this. So we're going to get the limit as a approaches infinity of putting a into this, so it's going to be minus 2 over a minus putting the 3 into that, minus 2 over 3. And as a goes to infinity, really large denominator makes the fraction go to 0, and we get 0 plus 2/3, so we get 2/3, and it's convergent. It converges. And finally, the last one. I give you a hint. See, where's the problem? 3 in here, it would be 2 and ln 2. That's not a problem. If I put 2 in here, it'd be 1 and ln of 1, but ln of 1 is 0. We can't have division by 0. So 2 is the problem. So we have to do the limit as a approaches 2 of the integral a to 3 of 1 over x minus 1 times ln of x minus 1. And I tell you to use a u substitution, And we'll do it for ln of x minus 1. So du equals 1 over x minus 1 times the derivative of that, which is 1, dx. You multiply by x minus 1. And so we get the limit as a approaches 2 of the antiderivative from a to 3 of 1 over x minus 1 times u, because that's what I let u be, and dx becomes x minus 1 du. So I have the antiderivative of u. Oh, and these are not the same because now I'm in u. But I get the limit as a approaches 2 of antiderivative of 1 over u is ln of u. Now I can go back and put in what u was, which is ln of x minus 1. So I got ln of x minus 1. Evaluated from, now I'm back in x, so a to 3. So I haven't done the limit yet. Put in 3 and I get ln of 3 minus 1, 2, minus ln of a, and those could be absolute value, but a is supposedly in the positive area, so it's not a problem. And what happens here? Well, that's a constant, so that's not a problem. Ln of a, ln looks like this, so it goes off to infinity, and ln of something going to infinity would still go to infinity, and so this one diverges.